problem may be with the wiring to the load or the load itself. Automated production systems use machine interface circuits to interconnect the various controllers. This enables the controllers to communicate with each other and coordinate their operations. Robots, computer numerically controlled machines, and machines using programmable logic controllers are commonly linked together using machine interface circuits, which may include SSRs. A machine interface circuit connects an electrical output from one machine to an electrical input of another machine. Discrete signals may be used if only a small number of signals must be shared between the machines. For example, Machine 1 and Machine 2 share two signals. Machine 1 outputs a signal to indicate that the part is ready after it has finished processing a part. Machine 2 is interfaced to Machine 3 using similar signals as between Machines 1 and 2. Machine 2 receives this signal, and when it is ready to receive a part, it outputs a signal to Machine 1 to indicate that it is ready to receive part. Machine 1 responds to the output by placing the part on the conveyor. An automated production system that is more complex may use a network such as Ethernet or Profibus to communicate between the machines. The network connects the machine controllers together, such as the PLC shown. Each PLC interfaces with the machine's sensors and actuators to control the machine and runs a program to control the machine's operation. PLCs also include built-in networking capabilities to communicate with other PLCs. One common application of an interface circuit is the use of a robot to load and unload parts in a CNC mill. Step 1. The robot loads a part, moves away from the mill, and then energizes an interface circuit to signal that the mill may now machine the part. Step 2. The mill performs the machining task and energizes a second interface circuit to signal that the robot may now unload the finished part. Step 3. The robot unloads the finished part, loads a new part, moves away from the mill, and then energizes the first interface circuit to repeat the machining process. What is the purpose of a machine interface circuit? Describe how to interface machines given their I/O characteristics. When two different machines are interfaced, the input of one machine is activated by the output of another, and sometimes vice versa. As an example, examine the application shown. Here, a robot that loads and unloads two CNC machining centers is controlled by a PLC that has been interfaced to the system. Robot loads lathe. After the robot loads the lathe, it must then signal the lathe that it can begin its cutting operation. When the lathe finishes cutting, it must then signal the robot to pick up the completed part. Controller connections. The transfer of the signals is accomplished by connecting the outputs of the PLC to the inputs of the CNC machine controller and connecting the outputs of the CNC machine controller to the inputs of the PLC. For example, an output of the PLC activates an input of the lathe controller, and an output of the lathe controller activates an input of the PLC. The type of connection used to interface two machines' controllers is determined by the compatibility of the machine's I/O modules. There are two types of connections: direct connection and indirect connection. A direct connection means that the terminals of one machine can be directly wired to the terminals of the other machine. A direct connection is used if the output of one controller switches the voltage the way the input of the other controller requires. An indirect connection means that the two machines are interfaced through a device, such as a relay, that electrically separates the two machine signals. An indirect connection is used if the outputs and inputs of the two machines are not compatible. If the machine controller has relay contact type outputs, it can be directly interfaced to any other machine's inputs. To do this, one of the machine controller's output terminals is wired to the other machine's input, and the other output terminal is wired to either the machine's source voltage or ground. If the machine's input is an active high input, the source voltage is used. If the input is an active low input, the common terminal is used. A machine controller's PLC solid-state outputs can also be directly interfaced to another machine's inputs, but only if the voltages and transistor types are compatible. They must use the same voltage range and the same type of logic. For example, if one machine controller has active high 24 volts DC output, the other machine must have active high 24 volts DC inputs. Output modules with active low logic can also be directly connected to a machine input if that input also uses active low logic. As with interfacing machine controller inputs and outputs, PLCs must be connected to devices with compatible power levels. Whenever possible, the same external power supply should be used as shown. By using the same power supply, voltage differences can be eliminated. When it is not possible to use the same power supply for two different machines, they must have a common voltage reference as shown. Differences in voltage levels can cause damage to the input and output modules. When inputs of one machine are not compatible with the outputs of another machine, an interface device, such as a control relay, must be placed between the two machines as shown. In this case, the PLC output of one machine uses 24 volts DC, and the other machine's input uses 120 volts AC. When the PLC's output 0 turns on, it activates the coil of the relay. The coil closes its contacts to complete the circuit to the input of the machine. Because the coil and contacts of the relay are physically isolated, the incompatible voltages never connect. A relay can also be used to interface a machine output to an incompatible input as shown here. When is indirect connection used to interface machines? When is direct connection used to interface machines?